Hello students, welcome back to the class. So we have already completed the chapter, I think. So some of the parts are left according to NCERT, but we will cover that part also in today's class. Apart from that, we will cover a very special topic from where questions are asked in the exams, which is eudiometry. So today's focus will be on this topic. Disclaimer: the images, text and other materials used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. First of all, our objective will be to convert, to cover this whole topic, which is perform the stoichiometric calculations. We have already been a way through, but some of the parts are left from it. Then we will see what is eudiometry. Okay, so it's very simple to understand. Just follow a simple process or a simple algorithm, which I will tell you, and then you will be able to solve the questions easily. If I talk about the specific topics, then in stoichiometric calculation, we will cover the reaction in solutions topic, then the problems related to it, eudiometry, and examples related to eudiometry. Is it okay now? Is my voice okay now? Hello, Abhi. Is it clear now? Kaushal. So what we will see is this 4 topic. Is my voice clear now? Hello, hello. So am I audible now? Okay. So let's start our today's class. First of all, I will tell you about the reaction in solution. In this, I will say deal with the concentration terms. Okay. So the first thing is about the concentration term, and this thing can be expressed in the following ways. Our first concentration term is mass percentage or the weight percent. Second is the mole fraction. Third is molarity. And fourth is molality. Now all of this topic are important to understand, and these are all related to the mole fraction. So you should be very clear about the say mole concept and what is molar mass and all. So that is important for you. Then you will be able to say cover this thing. So the first thing that we will study is your mass percent. It has a very simple relation, and that relation is, how do you calculate the mass percent? It is simply the mass of the solute divided by the mass of the solution multiplied by 100. Now do not complicate this topic. It is very simple to understand. Just take the analogy of your marks you obtain in your exam. Like if you are obtaining 80% marks or 90% marks out of total. So that same analogy can be applied here. And here you are trying to calculate the mass percentage of the solute. Okay, as simple as that. Clear? So mass and weight percent both will be same. So you can take both of them same. How you can take it? Because you know that what is the way to convert mass into weight. You must have learned this in the physics. You need a factor of 9.8, but that same factor will come in the upside and in the downside, and they will be cancelled out. So you can take them either as weight or mass. Okay, you don't have to worry about what is being said. So our first question on it. So I don't think I need to elaborate it furthermore. If I make you understand the question, then it is well enough. So the first question goes like this. You are adding 2 gram of a substance A to 18 gram of water. Okay. You are adding 2 gram of a substance to 18 gram of water. Then what is the solute here? The solute is the substance A whose mass is A, and the solvent is water whose mass is 18. Then you have to calculate the mass percentage of the solute. Yeah, it may be written in the solution question to calculate the mass percent of the solvent as well. So that would be simple, I guess. Just substitute the mass of solute with the mass of solvent and you will get your thing. So talking about the volume by volume percent, when we will move to the chapter solutions in 12th class, then you will see there that what is volume percent. But still, if you are willing to know about it, then it's very easy to calculate. Just take the volume by volume thing and you will get the answer. So let us see the correct answer. So as I am already getting many answers from the students. In this, we will simply use our formula, which is mass of A by mass of solution. So A is your substance multiplied by 100. If I keep all of this, so what is the mass of the A? Mass of A is 2 gram. What is the mass of solution? So don't take the mass of water itself, okay? Add 2 gram to it to take the complete mass of solution, because mass of solution is mass of solvent plus mass of solute. So 2 by 2 plus 18 into 100. Yes, you will be able to see this lecture in the website. Just go and check the website of Sathee JEE or Sathee NEET. You will get the same lectures, okay? If you do this calculation, you will get it as 10%. So the one who is getting 11%, so there is a mistake in that, okay? Just try to do the calculation once again. You will get that what mistake are you making, okay? So in this case, you have to take the mass of the solution and not the mass of the water. I hope it is clear now. Anyone has an issue in this question? So if you are able to solve it, you are good to go with this mass percent thing for any solution. Okay. Now moving on to the next concentration term. Our next concentration term is mole fraction. Yes, Hargum, what is your doubt? What specifically are you facing trouble in? You can just write it in the chat section. Is it related to the previous question? Okay, so just write your doubt. So I'm moving forward till that time. So what is mole fraction? Okay, so I will explain it once again. The question was saying that the mass of solute was, so solute was A there. It was 2 gram. Okay, mass of solute was 2 gram. What was the mass of solvent? So there we have taken water as the solvent. So mass of water was given 18 gram. And you have to calculate the mass percentage of solute, which is A. How you will do it? So it's a very simple formula. Whosoever percentage you want to calculate, keep it in the numerator. Okay. So it's very simple. If you are obtaining 18 marks out of 20, you take it this fraction and multiply it by 100 to get the percentage. That same analogy here. Okay. So what is the mass percentage of solute? It is given by mass of solute divided by total mass of the solution. What is the total mass of the solution? If I ask you, what is the mass of the solution? It will be solvent plus solute, right? It will be solvent plus solute. which will be 20, multiplied by 100. So that will give you 10%. Is it clear now? Okay. Now, moving on to the mole fraction. How do we calculate the mole fraction of any component? Okay, I will explain that last question also. No worries about that. So, how do we calculate the mole fraction? So, we have a very simple formula. Just keep the moles of the substance whose mole fraction you are interested in the numerator part and the total number of moles. Like, suppose you are interested in a solution who has two components A and B. Okay, then what will be the mole fraction of A? It will be given by number of moles of A divided by number of moles of solutions. Then what are present in the solution? A and B. What are the components? A and B. So the total number will be Na plus Nb, means number of moles of A plus number of moles of B. And again in the numerator, the number of moles of A. So in this way you will calculate the mole fraction of A. Now mole fraction is represented by this chi. So this is not x, it is chi, and whosoever mole fraction you are interested in, just keep it in the subscript. Okay, just keep it in the subscript. Okay, Moaz, you may go and visit our website for the Hindi version of the same lecture if you are having any issue. Okay, then if you have any doubt, you can join our doubt sessions also. Clear? So yes, coming back onto the topic, so this is your formula. So just try to analyze it. It's very simple. Now same thing can be said for the B. Okay, same thing can be said for the B. So chi is the mole fraction. So this is just a notation on how to write the mole fraction. Clear? Instead of writing this whole thing, you can write it as chi A. Remember students, this A is in the subscript, so it will look like this. So this will be the mole fraction. You can just write your doubt in the chat section. Then coming on to the mole fraction of B. How you will calculate the mole fraction of B? Again very simple. The moles of B divided by the total number of moles in the solution. One very important point. The important point is that if you take the mole fraction of each and every component present in the solution, then its sum will be equals to unity. So chi A is this thing. Okay, so this is your chi A. It is your mole fraction of A. It is just a notation to, it is just a way to write this thing. Okay, so if you are trying to write mole fraction of A, you can drop this whole phrase and simply write chi A instead of that. Now what about this statement that addition of all mole fraction is 1? Suppose we take again the example of the same solution that we have dealt with. So we have component A in that solution and component B in that solution, whose mole fraction is chi A and chi B. So listen very carefully, okay? Because if we move fastly, then we will be able to cover this whole topic because it's a large one. So again I am repeating it. Suppose we have our solution in which we have only two components A and B. Then chi A is the mole fraction of A and chi B is the mole fraction of B. Clear? If you add both of this mole fraction, you can get it as 1. Just try to derive this formula. How you will derive it? Put the value of chi A, put the value of chi B, and see that whether you are getting 1 or not. So this is a work for you. Again I am repeating it. Addition of all the components in a given solution. Okay? Addition of all the components mole fraction is a given solution is equals to 1. So mole fraction is basically a way of writing the fraction. How you can understand it? Suppose you have taken a whole cake and then you have divided it into 2 halves. And if you take 1 half of that cake, then what will be its fraction? It will be of course 1/2. Same way, similar to that, you can think of the mole fraction. So if you have say A and B, then A and B will have their fractions in the total solution. Now suppose we have a multi-component system. What is multi-component system? The solution which we have dealt with now was a binary solution. Two components were there, A and B. Okay. Now suppose we have more than two components, A, B, C, D, E. Then in that case, if you add the mole fraction of each and every component, then you will get 1. Remember this thing. You have to add the mole fraction of each and every component. Yeah, you can do it to calculate chi b by subtracting 1 from this. So it's very simple. Just bring this chi b here. You can calculate the chi a. So remember students, this formula is only applicable when you take the mole fraction of each and every component. Suppose you have 3 components, and if you add 2 components mole fraction, you won't get 1. You have to add the mole fraction of all those 3 components. Pratik, we can't go backward. There is an issue in that. So sorry for that. You can just go and check the website, and there you can get the screenshot. Okay. This lecture will be uploaded in 1 to 2 days. Don't worry. So remember this part. So this is a very important part, that the mole fractions addition of all the component will be equals to 1. Yes, it's true. So chi a plus chi b will be 1 if it's 0.25. Now moving on to the next concentration term, which is molarity. Now what is molarity? Just listen the definition very minutely. It is given by number of moles which are present in 1 liter of the solution. Okay. So if there were 3 say components, suppose there were 3 components in the solution instead of only 2, then the addition of all the mole fraction chi a plus chi b plus chi c will be equals to 1. Okay. What is concentration? Very good question. So what is concentration? Let's understand this thing. Suppose you have taken a glass of water and you have dissolved 2 grams of say sugar in it. Then someone asks you that what is the concentration, or what is the say what is the amount of sugar that you have dissolved. You would say it 2. Now suppose you have taken similarly 2 glass of water and you have dissolved that same amount of sugar in that 2 glasses. Okay, that 2 gram is dissolved in now 2 liters of water. Now in that case, you are still dissolving that 2 gram, but the amount of water that you have taken has been doubled. So you in this case you have to tell the other person that okay, now I have taken 2 grams of sugar, but I have doubled the volume. So you have to specify 2 things now. Clear? Okay, very good. Now to avoid this complexity of defining the solutes and solvent amount each time, we have taken concentration, in which we are taking the ratio of their masses, of their say moles and all. So that is the thing we do in concentration. I hope you got the thing. Now how do we calculate molarity? It is calculated by the number of moles of solute divided by the volume of the solution in liters. What? Number of moles of solute divided by the volume of solution in liters. So the volume should always be liter. And one very important thing is that 1 liter is equals to 1 decimeter cube. So this relation is very important for you, and it will help you to convert the volume unit each time, and unit conversion is very important in this chapter. So you should remember this thing. Okay, you should always remember this thing. Now how I am doing this? How do we do this unit conversion? Suppose you got our volume in centimeter cube, then you have to convert this thing into decimeter cube, then you will get the volume in liter. Okay, when we will do the questions related to it, you will get the idea behind it. So this thing is very important to understand, that 1 liter is equals to 1 decimeter cube. For the time being, you should remember this relation. How you will use it, we will see that in the question. Okay. Now what is the significance of molarity? Suppose we have taken 1 molar of a solution. means the molarity is 1. Now remember students, molarity has been represented by capital M here, and each and every time you will see capital M, it means it is molarity. So Nisarg, if you have any issue related to it, you will get this point after understanding the significance. Okay, so do not worry. You can get the recording. In the website. It's there in the website. Okay, so just visit the website Sathee JEE. You will get the thing. Okay. Now, suppose we have a solution whose molarity is 1. So listen it very carefully. Suppose you have a solution whose molarity is 1. Now, what is the meaning of this? It means that 1 mole of NaOH is dissolved in 1 liter of the solution. Again, I am repeating it. Suppose you calculated the molarity of a NaOH solution as 1. Then it means that 1 mole of NaOH is dissolved in 1 liter of the solution. Clear? Again, suppose you have taken 0.2 moles of a 0.2 molar solution. Then in that case, what will be the concentration? It will be 0.2 moles dissolved in 1 liter of the solution. So these two things are important. You must try to understand the definition rather than learning it. Okay. So again, I am repeating it. If I say that I have a solution whose molarity is 1, then it means that 1 mole of the solute is present in 1 liter of the solution, or 1 mole of the NaOH is present in 1 liter of the solution. Similarly, if I am saying that I have a solution whose molarity is 0.2, then it means that we have 0.2 moles of NaOH dissolved in 1 liter of water. Has anyone any problem with it? So Nisarg, sorry for that. If that is done with you, maybe it may be done by mistake. So we'll take care of that on the next time. So I will cover the Eudiometry also, Pratik, after this part. So if you are willing to leave this part, then well and good. So it's very important, I guess. Okay. So coming back to the point. So we have two types of solution. So we are dealing with the significance of molarity. So first of all, you have to understand that what is molarity. So molarity is something which tells us about the number of moles dissolved in 1 liter of solution. Like if I am saying that if a solution has a molarity of 1, then it means 1 mole of that NaOH is present in 1 liter of the solution. Similarly, if I am saying that I have 0.2 as the molarity, it means that 0.2 moles are present in 1 liter of a solution. Suppose someone asks you to convert a solution whose molarity is 1 m to a solution whose molarity is 0.2 m. How you will do it? Let's see that. If I am doing it in the lab, suppose this thing I am doing it in the lab, then what we will do is that we will take 0.2 molar solution. Okay. Clear? So for making 0.2 from 1, what we will do? We will take 1 molar NaOH. We will take 1 molar NaOH, and from that we will take that part of the solution whose number of moles is 0.2. Let us understand this. Okay, let us try to understand this once again. So our situation is we have a 1 molar solution and we have to convert it into a 0.2 molar solution. How we'll do it? So if your 1 molar solution, if you take 1 liter of the 1 molar solution, you will have 1 mole according to the definition. Okay. Then in 0.2 liter, what will be the number of mole? It will be 0.2 mole. Has anyone has any issue in this? They can ask if anyone has any how I have taken this 0.2 liter. Yes, Nisar, what is your doubt? So you are aware about the objective, right? So we have a 1 molar solution and we have to convert it into 0.2 molar solution. Okay, this is our objective, and we know that by 1 molar we mean 1 mole of NaOH is present in 1 liter of solution. Okay, so if we take 1 liter of 1 molar solution, then we will have 1 mole. Then in 0.2 it will be 0.2 liter, we will have 0.2 moles of NaOH. Two things are there. In our 1 molar solution, 1 liter has 1 mole of NaOH. 1 mole of NaOH. So if I want to take 0.2 mole, you have to take 0.2 liter of the same solution. Got it? Nisar, any doubt? Did you get the point? Yes, Abhi. Whenever you take a solution itself means that you are taking a homogeneous mixture, and in homogeneous mixture there are equal number of particles present throughout the bulk. Yes, NaOH means sodium chloride. When we will put Na? So I didn't get your question. So I'm moving forward. Just write your doubt. So till this point we know that we have taken a solution in which the molarity is 1 molar, but the number of moles is 0.2. Okay. Now what we will do next? Now we will add water to it. To that same 0.2 liter 1 molar solution, we will add water, and we will keep on adding till the solution has a volume of 1 liter. Till the solution of has a volume of 1 liter. So if it is so, then we are having our 0.2 molar solution. Okay. Now let me make you understand. I think that many of you would be facing difficulty in this thing. So let me do it with the help of a diagram. So that would be more good. Got. Now initially we have a 1 molar solution. Very good. And when we are saying 1 molar solution means 1 mole is in 1 liter of solution. Okay, no problem with it. Good. Now suppose out of this solution we take only 0.2 liters out of this. Okay, we take 0.2 liters. No, now if 1 mole is present in 1 liter, that means 0.2 mole is in 0.2 liter of solution. Any problem with this statement? So initially we have 1 molar solution, and by 1 molar we mean that 1 mole is present in 1 liter. Suppose we take 0.2 liters. That means 0.2 moles will be present inside it. Here we will have 0.2 mole of NaOH. Okay. Now we take that same solution whose volume is 0.2 liter, but the molarity is 1 molar. Okay. That means it has 0.2 moles of NaOH. Okay, so these are now our condition. Now we start to add solvent in it, and we will add solvent until this volume becomes 1 liter. Okay, so now we are only adding solvent, not the solute. So our number of moles is fixed, which is 0.2, but now our volume is 1 liter. So number of moles of solute is fixed, which is 0.2. Therefore, our new molarity will be what? It will be 0.2 molar. So this is the thing that I am trying to understand, that I am trying to make you understand. So I am again repeating the whole part. So just listen it very carefully. Suppose we have 1 molar solution. By 1 molar solution means we have 1 mole of the solute present in 1 liter of the solution. Now next what we do? We take 0.2 liters of the same solution and keep it in a different bucket. Now if 1 mole is present in 1 liter, therefore 0.2 moles will be present in 0.2 liter. Okay. So we have this solution where we have 0.2 liters volume, 1 molar as the concentration and 0.2 moles of NaOH. Now in this same solution, we keep on adding the solvent. So our solute moles are fixed. We are just adding the solvent. Therefore, the solvent's volume, the solution's volume finally become 1 liter. Therefore, your concentration is now 0.2 molar. Got it? Now, still if you are facing difficulty in this, we will look at a calculational trick to understand this. What is that trick? So that trick is very simple. Suppose we have initial molarities as 1. So listen it very carefully. It's very important. You will use this formula everywhere. So suppose you have the initial molarity as 1 molar. Okay. And initial volume, which is 1000 ml or 1 liter. The final molarity is what? The final molarity is 0.2. Okay. Then from here you can get the volume that you need to add. So the question will be asked in this way, that what volume of the solvent you should say add to decrease the molarity from 1 molar to 0.2 molar. So you will simply put the values here. So initially say suppose we have 1 molar solution and we don't know what volume should we take. So we will keep it as V2. Then here we will take 0.2 and here we will take 1. Then from here you can easily calculate the volume. If we put all this thing, then we will get V2 as 200 liter. Yes, we are basically diluting the thing. So when we will do questions on it, I think you will be able to understand it more clearly. So just go and listen the lecture one more time on the website. If you are still facing difficulty, you can come back with the same. Now remember that the moles of NaOH was 0.2 in 200 ml and it was remained 0.2 even after dilution. Therefore, we have just changed the amount of the solvent and we have not done nothing with this NaOH. So we are just diluting it further. One very important point, molarity is dependent upon the temperature, because molarity is dependent upon the volume of the solution. And if we increase or decrease the temperature, then the volume will also increase or decrease. Yes, it is 200 ml. Yeah, this will be 200 ml. Okay. Now moving on further. So here is a question for you. We have to calculate the molarity of a NaOH in the solution where we are dissolving 4 gram of NaOH in 250 ml of solution. In this question, a different thing is asked, Shaurya. It's a very simple question. You just have to calculate the molarity. There we were trying to change the concentration. Here we are not doing so. Okay. So how we will calculate the molarity? So I'm already getting some answers. So it is 1.6 from Pratik. How do we calculate the number molarity? It is number of moles of the solute divided by the volume of the solution in liter. Then to calculate the number of moles of NaOH, it will be mass of NaOH divided by the molar mass of NaOH. Okay, so this will be the number of solute, moles of solute. To get the number volume of solution, we divide this whole thing by 1000 to get the volume in liters, because we need the volume in liter. This was our definition. Now putting all the other values, which is 4 gram, and for NaOH the molar mass is 40, we get the final value as 0.4 molar. So this is the final molarity value for the given NaOH solution. Anyone has any issue in this question now? It's very simple to understand. Nandini, Pratik, Aditya, Nisarg. So if you are not getting that M1 V1 thing, we will talk about it in much more detailed way when we will do questions in it. Okay. So it's very simple to understand, I guess, this question. So again, I am repeating it. To calculate the molarity, we take the number of moles of solute divided by the volume of solution in liter. Number of moles can be calculated by using the formula, which is given mass by molar mass. So given mass of NaOH is 4 gram and molar mass of NaOH can be calculated as 40 gram per mole. Divide by the volume of the solution, which should be in liter. So 250 converted to liter will give you 0.250. Just divide this whole thing by 1000 to get the volume in liter. Finally, you will get it as 0.4 molar. Okay. Now our last concentration term, which is molality. How do we calculate molality? There is a very small difference. In the numerator, we will still have this number of moles of solute, but in the denominator, we will have the mass of the solvent. Remember, the mass of the solvent and not the solution. Mass of the solvent, and that also in kg. So two things are important. In the denominator, you will take the mass of the solvent, and the mass should be in the kg unit. So here we denote this molality by small m. Molarity was denoted by capital M, and molality is denoted by small m. So there is only one difference in letter in both their pronunciation, which is molarity and molality, L and R. Therefore, we can write the formula as this, which is number of moles of solute divided by the mass of solvent in kg. Okay. So this is the way we can calculate the molality, which is number of moles of solute divided by the mass of solvent. See, we have taken the mass of solvent and its unit should be in kg. Now we have a question. Again, we have a question related to it. So you will understand this thing, Nandini, with the help of this question. If you are facing difficulty in molality. Suppose we have the density of a 3 molar solution. See students, this is the molarity because it has a capital M against it. Okay. Now the density is given as 1.25 gram per ml, and you have to calculate the molality. What you have to calculate? You have to calculate the molality. How will do it? So we have the molarity. So capital M is the molarity, or its unit can be also written as 3 mole per liter. Now I have already told you that what is the moles of NaCl that would be present in 1 liter of the solution. If its molarity is 3 mole per liter, it should be 3 moles. Okay, it should be 3 moles. Any issue in this part? So 1 liter of this solution will contain 3 moles of NaCl. Okay. No, molarity and molality are of course not same, Nisarg. So molarity formula is number of moles divided by volume of solution in liter, and molality formula is number of moles of solute divided by mass of solvent in kg. Okay. So let's see if we need to round, you can round off or not. Okay. So what is the mass of NaCl that is dissolved in 1 liter? It will be 3 into 58.5. How it is coming? When I'm saying that 3 mole per liter, it means 3 moles of NaCl is dissolved in 1 liter of solution. So this is the definition of molarity. I have already mentioned it. Now if 3 moles is present in 1 liter of NaCl solution, then from there we can calculate the mass. Moles multiplied by the molar mass will give you the mass that is present in 1 liter of solution. Next, so 58.5 is the molar mass of NaCl. It is 23.5 plus say 23 plus 35.5. Then what is the mass of the solution? So students, please look at this thing. I am using my whole effort to make you understand this. So do not deviate from this topic, okay? If you want to talk anything else, then you can go anywhere else, okay? So what is the volume? It is 1 liter. So 1 liter is being converted to milliliter by writing 1000. And to calculate the mass of 1 liter, we are simply multiplying the density with the volume. If you do so, you will get the mass of solution as 1250 gram. So we have used the formula of density, which is mass per unit volume. So from there, we have calculated the mass of 1 liter. Remember, I have taken here 1000 ml because density was given in gram per milliliter. Now next, what we will do? Now in the next part, we are now focused on calculating the molality. We have the mass of the solution. We have the mass of the solvent. So 58.5 is the molar mass of NaCl. So we have the mass of the solute. We have the mass of the solution. Just subtract both of this to get the mass of solvent. Okay. Then once we got the mass of the solvent, convert this thing into kg. Then you will get your molality from here, which is 2.79. Now I will try to re-explain this question once again if anyone is facing any issue in whole of this. Okay, so let us try to understand this thing one by one. Density is given as 3 molar. Okay. Second thing, we have the, sorry, not density, it is 1.25 gram per ml. So just listen it very carefully. Second thing is molarity, which is 3 and the capital M. Okay. Two things are given. When we are saying, and this all is for NaCl. When we are saying molarity, it means 3 moles of NaCl is in 1 liter of the solution. Which solution? This NaCl solution. Okay, so this is very obvious. I have already mentioned this thing. If this is the molarity, so molarity is what? Simply it is the number of moles in per liter of solution. So there are 3 moles per liter of solution or 1 liter of solution. Then what is the mass of NaCl in 1 liter? Mass of NaCl in 1 liter, it will be number of moles multiplied by the molar mass, which is 58.5. If you multiply this thing, 5 3 are 15, 5 8 are 40, 4 carry, 5 3 are 15. Okay, just calculate this thing. I think you will get. So 5 3 are 15, 1 6, 5 8 are 40, 41, 15 and 4. That will give you how much? 19. Okay, so you will get the mass of NaCl from here. So if there is a calculational mistake, you can try this once again. So we got the amount of NaCl that is being dissolved in 1 liter of this given solution, which is 175.5. This will be 175.5. Till this point, anyone has an issue? Okay. Now, what is the mass of the 1 liter solution? Mass of 1 liter solution. So we have the density of solution, which is 1.25, and it is in gram per ml. Okay. And what is the amount that will be present in 1 liter? Of course, it will be 1 liter. You have to convert this thing into milliliter. So multiplying it by 1000, it will give you, so 1.25 multiplied by 1000 will give you simply 1250. So this is the mass of the solution. And how much solution? 1 liter of solution. So you have the mass of NaCl in 1 liter of solution, and you have the mass of solution also. So we know that mass of solvent plus mass of solute gives us total mass of solution. We know this thing. Okay, we know this thing very often. Now, what is the mass of solute that we have calculated here? It is 175.5. And what is the mass of solvent? This thing we have to calculate. And this whole thing is equals to 1250. So, 1250 subtracted from 175.5 will give you how much? It will give you 1074.5. Okay, 1074.5. So here it will be 17.5. Okay, sorry for this. So this will be 17.5. So are you getting this point? This whole calculation. So I have done this thing once again. Now once we have the mass of the water, we have the number of moles of solute, which was 3 moles. Okay, then convert this gram thing into kg and you will get the molality. Now this is your way to solve it. Now moving on to our today's last topic, which is eudiometry. So I will tell you about eudiometry now. There will be questions on it. We will talk about it tomorrow. So just try to understand the theory today. If you are well aware about this theory, then you will able to solve the question. Still you have the problem. If you have any problem in theory, your problems will be solved in the question part. So what is the use of eudiometry? We will not go that much deeper into the experimental setup. Our main goal is to solve the question or the numerical. But still I will give you a greater perspective related to it. So it is basically used in the gas analysis that is involved in a reaction. So many reactions involves gases. So our eudiometry is related to that thing. And we do it with the help of volume. And this analysis of gas mixture with the help of appropriate adsorbent is called as eudiometry. Okay. Suppose we have the combustion of hydrocarbon. So this is the general equation for hydrocarbon. You can see it very clearly that our hydrocarbon O2 and CO2 are all gaseous. Now what will be the amount of gases that will be released, and what is the hydrocarbon that we have? This thing is the main goal to be done in our eudiometry topic. Okay. Now how we'll do it? To understand this, we have to first of all take some assumptions. Those two assumptions are Gay-Lussac's law of combining volume. So I have already mentioned about it. You can just read this statement. where we say that the gases combine in a fixed volume to give the product, and this ratio of these two volumes are in a simple whole number way. Similarly, we have the Avogadro's law, which tells us that equal volume of all gases at same temperature and pressure will contain equal number of molecules. So I'm not discussing about it in this class. We have already seen what is Avogadro's law and Gay-Lussac's law, but we will use these two laws here. Now coming on to the next thing, what are the adsorbent and the gases that are adsorbed? So if you take NaOH and KOH solution, then CO2 and SO2 are adsorbed. Similarly for alkaline pyrogalol, O2 is absorbed, and similarly for rest of the given gases we have this kind of adsorbent. Now let us try to understand the experimental setup for this. Okay. So what we do, say we have a burette. Okay, we have a burette like this. We have a burette, and in this we are doing the combustion. Okay, and this burette is being attached to a adsorbent, and here we have a tube. Okay, here we have a tube which is half filled. We start burning our component in which we are interested in. Now after burning, there will be accumulation of gas here. Now this gas will travel whole through this and go into this burette and will be get collected in the top. Initially in this burette we have only the solvent or the adsorbent present inside it, but after this burning we have also some gases which were released in the gaseous mixture present in this available volume. Now we will analyze this volume, then we will try to get the thing that we are interested in, which is molecular formula. So we'll talk about this in the next session. So there are still questions related to it, which I am leaving it for today because we are having a lack of time. So thank you for attending the lecture. We'll see it in the next class.